The answers make a good point about this question, in that often we are using lengths or relationship between lengths to work out relationships between areas, whereas here, actually, we know that the hexagon is 6 times the shaded area, and we're trying to work out a relationship between the lengths. So a nice little twist on things. So first up, I'm going to label the sides of the hexagon X, and I'm going to try and find out the area of the whole hexagon in terms of X. And to do this, we can split it into six equilateral triangles, because the hexagon has angles of 120. So like if you cut across, you're going to get 60. Same here and here also. You can also think about doing 360 divided by 6 to give 60 there. So let's find the area of one triangle. Two ways to do this. Really quick way is to use a half AB sine C. So it's going to be a half times x times sine 60. And this is where your exact values of trig come in. So in the answers, they show two different ways to do it. They avoid using exact values of trig, but I think other aspects just make it more complicated. So if you're attempting the latest questions in the Intermediate Maths Challenge, you've just got to learn your exact values of trig and be ready to use them, I think, because it comes in useful here. So we're going to get root 3 over 2, and therefore the area of the triangle is root 3 over 4x squared. Now the other way to do it, if you don't know your exact values of trig, you can still do it. So you split your triangle into two. This is then going to be a half x. And to get the height, I can use Pythagoras' theorem. X squared minus a half x all squared, just a quarter x squared square rooted. And that is going to be 3/4 x squared square rooted, or root 3 over 2x. So the area then becomes a half times the base times the height. And again, we get root 3 over 4x. Right, therefore, the area of the hexagon, and ideally, like you want to practice this and be able to get this really quickly. Okay, I know I've talked about it for a while, but it's just to illustrate what's going on. We times by 6, so we're going to get 3 root 3 over 2 x squared. Right, nice. Now let's work out the area of that shaded pentagon. So, as I've said, this is going to be x, and this is going to be x. Okay, but what about the other lengths? Well, what we can do is draw a vertical line, r to t, and then split it into two triangles. This is 90 degrees and this is 60. So if I want to find the opposite of this triangle, then I can use sine 60 is opposite over x. So opposite is going to be sine x times sine 60, which is root 3 over 2x. Brilliant, I've got this height. I've also got the height of the whole hexagon. It's going to be double that, so root 3x. Sorry, that should have been an x there. And then similar over here. Cos 60 is going to be the adjacent over x. So the adjacent is going to be x times cos 60. Cos 60 is a half, so it's a half x. So then I'm going to get a half times base times height. That's going to be one of the triangles. But if I want both triangles, I'm going to need to double it. And then these just cancel out. And then I've got to find the area of this, the rectangle, but that's the bit I don't know. So I'm going to label it L. Okay, that width there. And then it's going to be root 3 x L. That's the area, the shaded area, I should say. Because now we can get a relationship between x and L by using the fact that the area of the hexagon is 4 times the area of the shaded area. The shaded area, sorry. So therefore, 3 root 3 over 2 x squared is equal to 4 times, I'm going to bring this together now. I'm going to get root 3 over 4x squared when I simplify this, plus root 3xl. So I think I'll multiply the bracket out first. 4 root 3x squared. No, wait. Sorry. Forget that. The 4 cancels with the quarter. So I'm going to get root 3x squared plus 4 root 3xl. Now, because there's a common factor of root 3, I can actually just divide by that, get rid of that third. That's going to make life a little bit easier. And the same actually goes for an x. I can divide through by x. And then I can multiply through by 2. Get rid of that fraction. So 3x is going to equal 2x plus 8l. And we're nearly there now because we've got x in terms of l. It's simply x is equal to 8l. Let's just return for a moment to the original question. I didn't really talk about this a lot, but we're trying to find the ratio of the distance j walks to the distance k walks. J walks clockwise from P to Q, so, along the shaded area, and then k walks anti-clockwise, so along the unshaded area. We're trying to find the ratio of the distance that j walks to the distance that k walks. All right, so I'm just going to start a new diagram. Okay, let's focus on j to start with. So j is going to walk this amount here. L plus x plus x plus L. So actually 2L plus 2x. But x is actually 8L, so it's 2L plus 16L, walk in terms of L, 18L. K then walks along here. So this actually is x minus L. Oops. And x minus L. So K walks 4x minus 2L. 4 times 8L is going to be 32L. So 30L. And the ratio is therefore going to be 18L to 30L. Cancel the L's out. Divide through by 6. Gives us a final answer of 3 to 5. Wow, really nice answer there. Okay, big fan of this question. This is one way to do it, using exact trig. Have a look at the solutions as well for alternative ways. And yeah, well done on this question.